Yes, today we want to look at partial differentiation. Partial what? Differentiation. And look at this question. They say a function f that is of x, comma y, comma z. That is, the function is of x, y, z, which is 2x power y squared plus 3yz squared plus xyz plus s squared plus y squared plus z squared. The question is find partial f, partial x, partial f, partial y, partial f, partial what? Z. But here is the second derivative, partial derivative. With respect to what? X. This is second derivative with respect to what? Y. And then this one, fzz, means second derivative with respect to z. Now, f of s, that is f partial s, means is the same as writing this, that is partial f partial s, is the same thing. So now, what it means is we are going to differentiate this guy, but anywhere we see x, that is where we differentiate. That's what we call partial differentiation. Anywhere we see x, like if you check better, we have 2xy, so there is x here, so we have to differentiate this one. So differentiating x now, we have what? 1 here, so we now have 2y squared. Move here, 3yz squared, there is no x, so we have nothing to do with that one. When you check here, xyz, because there is s here, differentiate x, you have 1. Right? So it means we have yz, because differentiating x, you have 1. When you move again, look at s squared. Yes, because we are differentiating partially with respect to x, we have to differentiate this guy. The answer is what? 2x plus y squared z squared. So since there is no s there, so we stop here. And then look at this one. They say f partial y. It means that is partial f partial what? Y. So we differentiate f partially with respect to what? Y. So anywhere we see y, that is where our attention should go to. Now 2xy squared, there is y here. Differentiating this y squared, we have 2y, so and there is 2 here. So we now have 4xy, alright? 4xy plus there is y here also. So differentiate y, you have 1. We now have 3z squared. So there is y here again. Differentiating s, y, z, you have what? xz. We just do away with y, because differentiating y, you have 1. Plus, there is no y here, so here will be 0. But here, y squared, z squared, so it will be 2yz squared. We are done with that one. We move ahead. F partial z, that is partial f partial what? Z, equal to, now we are not going to check anywhere we see z, that is z. That is where we'll differentiate. 2xy squared, there is no z here, so we forgot about this one, but there is z here. So differentiating z squared, you have 2z. So that 2 multiplied by 2, you have 6yz plus there is z here. Differentiate this z, now we have 1. So we now have xy. There is no z here, so now is 0, but there is z here. It will be 2y squared z, because when you differentiate z squared, you have what? 2z. Now we are done with the first derivative, this. Now we are asked to find partial f partial s, that is the second partial derivative of f with respect to x. And now it means we are going to be using the first equation here, because now we have partial f partial x. Now when we differentiate equation 1, we have what to call fxx, that is partial f then partial what? X, that is square. Alright? This is second derivative. Now we are going to make use of this one now. So differentiating this one, remember, is still with respect to x. So since there is no x here, we have nothing to do with this one. There is no s here, we have nothing to do, but there is x here. So it means differentiating these 2x, now we have ordinary 2. So we are going to go here. Now the second one, they say fyy, that is this second partial derivative with respect to what? Y. We said that you write it this way or this is the same thing. Now our attention to go to equation 2 now, because when we differentiate this one twice, it will give us the second partial derivative. Now there is y here, so our mind should go here. Differentiating this guy will have 4x plus there is no y here, so here will be what? 0. There is no y here, to be 0, but there is y here. Differentiating this y, you have 1. So therefore you have 2z squared. So this is also okay. And finally, let's say find the second partial derivative of the function f with respect to z. So we will now say f z, which is equals to second derivative like this. That is the second derivative, the partial derivative of f with respect to what? Z. Now it's going to be equal to what? Our mind should go here. We are going to use equation 3 now because this is a partial f partial what? Z. Now our mind should, anywhere you see z, look at z here. So differentiating this z, you have 1. It means you have 6y, alright, plus now here there is no z, so we should not differentiate it. We'll leave it because it will be 0. But here there is z, so when you differentiate z, you have 1. So we have 2y squared because differentiating z now will be 1, and we are also good to go. I believe this is very, very simple. Thank you.